Hi, I'm Lytical, and welcome to Beyond Binary Class 4. I hope you had a fun time cracking all of those codes I set up for you. Today's lesson is going to be all about computer memory, how it affects your code, how much memory there is, where it all goes, what happens when we declare a variables, how much space there really is, and how to fit all of your data in there. Last class, we were talking about arrays and binary. So how does your computer store that in memory? But before we talk about that, if you have not seen that episode, there will be a link in the description. And so you don't miss any more episodes, leave a comment below, like the video, subscribe, and ring that bell. Thank you. There are a few kinds of storage: RAM, ROM, and hard disk, just to name a few. The one you're probably most familiar with is hard disk. That's where you've got all your files, all your pictures, your videos, any of your content. And to your hard drive, you can add new files, you can delete them, you can edit them, and when you turn your computer off, that data stays where it is, or at least you pray that it does. I know I have fallen victim to a faulty hard drive. Let's not talk about that. Another one you might have heard about is RAM. This is super fast memory. RAM stands for Random Access Memory, and that's because when you open a file, that file gets put into the RAM so you can interact with it, you can crop it, pinch it, zoom it, filter it. But if you haven't fallen victim to the faulty hard drive, you probably have fallen victim to at least a RAM issue. When your computer turns off and you haven't saved your file, all those edits are gone, and you are mad as hell. Because you worked hard. You were editing that document, you were face-tuning that photo, you were editing your videos. RAM only works when it's connected to power. Modern day computers are doing things to make it easier for you. They'll do auto saves, they will back up the RAM into the hard drive, so if your computer shuts down unexpectedly, you can hopefully return to a peaceful state of restored data. But otherwise, that data, it's not gonna persist. The final type of memory we're gonna talk about today is ROM, and it is just as fast as RAM, and it's not gonna delete your data if it loses connection to power. So why wouldn't we use this for everything? Well, ROM stands for read-only memory. So you can only read stuff from it. No writing allowed. Really, you're not going to interact with this that much. This is kind of your computer firmware. Any kind of data that helps your computer talk to the software in it and mixes it all together. Nothing too exciting here. If you are going to buy a computer or a friend asks you, hey, I'm thinking about buying a computer, I need some information. What's this RAM? What's this hard drive? How much data do I really need on my computer? I'm going to give you the information that you can give to them and be that tech witch that they all think you are. So if you're storing a lot of images, a lot of videos, you're going to want a big hard drive. Yeah, you could store some of that in the cloud also, and you can use the cloud, a Google Cloud Drive, Dropbox, whatever. You can use that to store all those files if you have a small hard drive. But if you're looking at RAM, you do not want to skimp on RAM, especially if you do a lot of powerful things on your computer. If you're coding, if you're editing videos, if you're photoshopping, you want a lot of RAM because every time you open an application, it puts all of that data into RAM. So you want to have all that data in RAM. You don't want to have only part of it. So if you're doing a lot on your computer, get big RAM. If you're just going to edit some documents, watch Netflix and chill, you probably don't need a lot of RAM, and you will be fine with a smaller RAM computer because RAM is expensive. I like to have a lot of RAM and a lot of hard drive on my computer so I can edit all these videos for you and, of course, store all my nudes and embarrassing singing videos. And you'll also commonly see that hard drives are going to be a lot larger than RAM on the terabyte, multiple gigabytes, because hard drives are a lot cheaper than RAM. RAM, you might see up to 4 gigabytes, and that would be a lot of RAM, at least in 2019, where we are right now. On this fancy schmancy MacBook Pro 2018 edition, I have 4 gigabytes of RAM and around 500 gigabytes of storage. And this is great for all that work I just mentioned. But if you're just learning to code, you do not need a fancy machine like this. In this class, all the coding we've been doing is in our browser. So you just need a computer with a browser. You could even do it on a tablet, as long as you get a keyboard, because the typing might be a little bit of a pain on the tablet screen. So while I've got this fancy machine here, I think it makes a lot more sense to talk about RAM, ROM, hard disk, or not even hard disk, on a computer that I loved when I was growing up from my childhood, a Game Boy. And we can talk a little bit about Pokemon, gotta code 'em all. So back in the day, with the Pokemon games, they were under a megabyte. The thumbnail for this video is bigger than a megabyte. We're talking real small. The Pokemon games used ROM and RAM. In the ROM, they'd store the gym leader names, the item names, different badges, different maps, different Pokemon. What else did they store in there? Just all of the content in the game. And you can actually pull up the entire map of all the ROM. I'll link to it below because it is so cool to see. They have all the music in there. I'm such a geek when it comes to all of this. So they would fill out the ROM with some of that information. And then in the RAM, they would have the status of your game, which Pokemon you had, which gym leaders you had beaten, what was your name, and they'd load in the sprites of the game just so they'd be able to display faster, just like we did in Scratch, we had sprites. And there is another map of all the RAM that's used in the game. I'll link this below. Again, such a geek moment. So yeah, the RAM had the status and everything that got lost when you forgot to save and your power ran out. But speaking about status, please make sure you get tested regularly. So people have spent time decoding how all the Pokemon games are built to make this map of the RAM, to make this map of the ROM, and they've been able to manipulate that in ways to do crazy cheats in the game, to do speedruns and all these cool things. There are a ton of cool videos, I'll link some of them below, where people do this. So how does this apply to JavaScript? So under the hood, the RAM, hard disk, and ROM, and other types of memory that I haven't mentioned, they're kind of just like a big block of data, kind of like an array of bytes and different kinds of data that you're going to store in those bytes. And you know all about bytes from last episode, so I'm sure you're a pro. Let's pull the memory back up on the screen and let's wrap it around a little bit so there's more room for my beautiful face. When you create a variable, let's say let number equal 1, 2, 3. Sorry, it's a little boring, but numbers can't be that funny, can they? So let number equal 1, 2, 3, and we'll get a little block of memory in there. In JavaScript, we could say maybe give us 64 bits or 8 bytes, and that will cover most of the numbers that we're ever going to need to deal with. And if we need something bigger, we can deal with that in another way. For strings, we could say maybe let my name equal Anna, and then get a bunch more blocks in memory. And we could just say for all strings, maybe give us 100 bytes by default, or some big number, because right now we're dealing with modern computers and they have a ton of storage, so it doesn't matter that much. What might we do for an array? We know an array is really a list of other properties. It could be an array of Booleans, it could be an array of numbers, strings, any of those types. So how do we deal with that? Back in the day, in several programming languages, Java, C, C++, you have to declare how big your array is and the type it's going to be. So in Java, you might say, my favorite numbers equal an array of integers that has 3 integers in it. And you'll get a certain block of memory for 3 blocks of integers, and that's all you're going to get. And they're all going to be right next to each other. So when you're doing your for loops, you can go really quickly through each one. In JavaScript, we don't have to deal with this as much because of the layers of abstraction. As a wise donkey was once told, ogres are like onions. Drag is like onions, and JavaScript is like onions. Oh my god, I actually have an onion. This is JavaScript, then there's C++, Let's see if I can get another one. Then there's C, then there's like assembly, and I don't even know what's beyond that. That you're just talking to the binary, to the transistors, all of that. My JavaScript is an onion metaphor, served gorgeously on a dish. Drag is just references upon references upon references. Aquaria was influenced by Sharon Needles, who was influenced by Alaska, who was influenced by RuPaul, and I could keep going on. They took what existed, brought their self into it, and changed it a little bit to be more modern and to be more for them. JavaScript was built upon other programming languages, and it took all the things that people liked about it and made those easier. In C++ and C, you have to manage all this memory yourself. You have to say, I want the array of 5 integers. I want the array of 3 strings. And that's really kind of annoying because you just want to focus on building a cool app, learning to code. You don't necessarily want to think about all the memory. You're dealing with a big computer that's really fast or a phone that's really fast. Browsers, we know they're going to be fast. They're not a small IoT device or like a small computer from the 90s, or I guess a large computer from the 90s. We don't need to care that much about the memory. So it's nice that that's abstracted away in JavaScript. If you want to learn how all this memory gets managed, and I think it is important, then you can go to Harvard. Yes, Harvard. I'm not kidding. They've got this great class that I mentioned in the first episode of Beyond Binary, CS50. It is a free open course, Introduction to Computer Science. A lot of this content is based on that. So go check it out. And all of this stuff is going to be done in C. You'll learn about memory. I just do not have the time to teach you all of that when it's already out there. All right, get in, losers. We're going coding. This class is all about computer science. But if you've seen any of my other videos, I show a bit about website development, a bit about app development, because I want you to learn how to build all of those things and to take part in building the technology around you. When you're building your websites or your apps, a very common thing you're going to have to deal with is CRUD. So much CRUD here, so much CRUD there. I'm not just talking about annoying things with developing. I'm talking about create, read, update, and delete. This is one of the most common flows in any application. In every application you have on your phone, go check it out. Maybe when you're making a profile, you have to create it. You might be able to update it. You might be able to delete that account. And you also want to be able to read other people's accounts. So we're going to play with arrays and kind of make a toy drag show management tool. I think this is something very needed. And maybe after this course, you can learn a little bit more about web development or app development and build this into a fully fledged application, which would be so great because at the drag shows I go to, they could use a little bit of help. Shaquita, we don't need 20 performers at Drag Wars. So let's dive into the code. I'm going to go into CodePen and let's open up the blank template as usual. And again, create pen from this template. Scoots the JavaScript over to the side. And let's just rainbow print an array of performers to get started. I'm going to use queens that are some of my drag sisters from Drag Wars. Rache Marseille, Vicky DeVille, Didi Fuego, Jasmine Kennedy, and go check out all of their Instagrams. I know I should obviously put myself, Lytical, and let's put this in square brackets so that it knows it's an array. Close this. Oh my God. Run it. Let's call it print rainbow. I feel like I'm brand new here and I'm the instructor. Mess. Well, let's actually do it in a for loop so it's a little easier to read. Just to practice again with for loops and arrays. I equals 0, I is less than. Let's make this into a new variable. Print rainbow, ln, performer at I. All right, and here is my drag show lineup. Maybe I'll even put a message at the top. Print glitter. Welcome to Drag Wars. And this is kind of an easy way to create an array, but another way we could do this, if we know how long it's going to be, we can do performers equals new array, and then 5 is how many queens we want to have be able to perform. And then for each one, we could say which queen it's going to be. But if you're just declaring an array in JavaScript, it is much easier to use square brackets and then do the list. And here we're going to get undefined for all the other ones. So let's exit that. So each of the ways you declare performers like that will put memory in our RAM for a length of 5 strings and give us a whole block of data for that. So that's great if we only have 5 performers. If we want to update any of these performers, we could do just access the element directly. So maybe Didi Fuego couldn't make it because she's doing Woman Crush Wednesdays at Hardware. I don't know, maybe there's a Monday, Wednesday conflict, and maybe Egypt will be performing then instead. So we can get an updated list of queens that way. Let's say we didn't know who was performing and wanted to maybe create a button and have a function that would let people add their names to the list, and then that would create the performance order. So let's clear out this array. Let's actually do it the other way. New array. We'll do 5. I guess there are going to be 5 slots. And I'm actually going to throw in an HTML button. Don't worry if you don't know any HTML, feel free to check out some of my other videos on it. But for this purposes, I'm adding a button that will call a JavaScript function. That way we can have a different kind of input rather than just running through exactly what we have in our printed JavaScript. We should probably have a little message in there that says add. And this is kind of an ugly button, so I'm actually going to generate some gorgeous styles for it with this button generator. Let's just make it purple all the way through. Purple. Make it big and long. Let's get the code for this. And then all I have to do is add this into the CSS. So much better. And we could create this add function. Who's performing tonight? We'll just call it P so it's a little easier to type. And right now this array is empty, or it might not be empty. It might have some added to it. So we basically want to find the first slot in this memory, in this kind of block of RAM that's undefined or empty. So why don't we do a for loop? Let's actually do this in a while loop to review that. A while loop is great if we're doing a condition with this loop. So we were going to go through this loop until we find the first one that's undefined. But if we can do that all in one line with the while loop, that's so much easier. Well, it's undefined. Check until the first I is undefined, and then we'll define the performer at that value. So performer's I equals P. And I also added a new function called clear text that will clear any of the text on the screen. And then we can maybe create a new function that just print show. And print show can just be all the stuff we printed before. And in fact, let's even clear the text before we print the show. That way, every time we want to print show, we don't have to call it again and again. Well, let's see if any of this works. So add who's performing tonight. Egypt. Okay, add another one. It's working. It's scrolling down a little bit. Let me fix this 1 second. Let's try this again. Egypt. All right, now it's working. And this is really starting to kind of look like a bit more of an application. We can add. Now what should we do if we want to edit? So maybe we can make a new button for editing. And what should editing do? So maybe editing, we can give it the index of a performer and then maybe change who it's going to be. Let's actually just change this to performer so it's a little more inclusive. I was actually just at DragCon of whenever it was. I don't know how long this video will take to edit. And there were so many amazing performers there, and I actually got to meet Axel Andrews, and I follow him on Instagram, and it was so cool to see someone so polished and not even doing kind of the glam femme look. They were kind of doing polished femme, mask femme. I don't even know, but whatever it was, doesn't need labels. It was so cool. So we do not want to be exclusive. Then we'll reprint the show, and let's actually add the indexes so it'll be a little easier to know who's performing when. All right, so we can add Rache, you can add Vicky, you can add Didi, you can add me, and then, oh no, I messed up all of my makeup and don't want to perform. So I want to change the third performer. Let's change them to be Jasmine can fill in for me. And now that's updated. So we've got create, we've got update. Another form of update might be to swap queens around. Let's say we already kind of know the order. So I'm going to redefine it back to what it was before. So we've got a few performers that are going to be going up. And one of the cool things with Drag Horse is that if you win one week, then you are the end performer the next week. So Rache, she always brings it, voguing down the house, boots, house, voguing. I can't even describe with words how much of a legend. So we got to put Rache at the end. So maybe we could add a swap function that would move Rache to the end and take whoever was at the end and move them back to the front. Let's add in this just the swap button already, so we're ready for it. We'll do performers I equals performers J, and performers J equals performers I. Let's run it and see how this goes. All right, you know what? Rache didn't win because this 0 isn't working, so I guess Vicky could be it. And then swap with Egypt at 4th. And after all of that work, now Vicky's disappeared. We just have Egypt twice. So what is going on? Well, I've got a fun example for you. It's late. It's a Tuesday. Oh, we're going to drink a little bit. Let's say you're a bartender and they ask you for a glass of wine. We might have more. We'll get there. And then their friend, or even you're just hosting people at home, their friend asks you for a little bit of rum. You hand it to them, and they realize, why is my rum in a wine glass, and why is my wine in this other glass? I want it in the other glass. And the customer is always right. So you're struggling a little bit. It's 2019 and gay bars are not as popular as they used to be. So you don't want to chuck these away. How can you swap these and give them the right order? Well, you're going to need another glass. Take this other glass that's empty. Pour the rum in it. Now the rum's in the right glass. Then take the wine glass that's now empty. A little bit of rum still left. Pour the wine in there. And now everything is right in the world. I love my Chardonnay flavored with rum. Sickening. We're gonna leave this here. So that's kind of what's going on in our code. We have two things that we're trying to swap, but we don't have a third place to store them. So all we need to do is just create a temporary variable. Let temp equal performers at I. And then instead of setting performers J to performers I, we're going to set it to this temporary variable. And let's run this. See if it'll reset. Just going to save it and refresh because everything is a little broken today. So now when we swap Vicky and Egypt, it happens correctly. And now you have a much easier way to manage who's in the queue. Maybe I don't want to be third. I want to be first or I want to be the second person, first index. So we'll swap 3 and 1. And now we have a much easier way to just manage this queue. At home, I'll give you this code and I want you to create a delete function and maybe a way to add new queens to this list and just play with this to see what kinds of buttons you would want in your drag management tool and how you'd want someone at the bar to interact with this. And maybe if you send me that, I could teach an episode on how we would turn something like this into a full application or into a full website that could be used by all different kinds of bars around the country. And now that is taking technology into all of our hands. And I'm going to take this wine into my hands too. That is all for this lesson. We covered a little bit more about memory, about arrays, Pokemon, references, memory. I already said memory, but clearly mine is going. If you loved this video, comment on it, like it, subscribe, ring the bell, share it with your friends. It means so much to me when you do that and when there's so much interaction on these videos. It shows that we want more LGBT people to learn about coding in a fun way. Again, just to review what I want you to do at home, I want you to expand on my drag wars or drag performance management tool, add a delete function, maybe add other functions that you think are going to be interesting. Anyway, that is all. I look forward to seeing you all so soon, and go and get coding. Bye.